Hi, I'm Benny D, and in this video we're going to be looking at the area under a graph. Okay, so when we're talking about the area under a graph, we really mean the area between a graph and the x-axis. So for example, like I've got a little picture here. So I've got some function, okay, we want to know what the area is between this curve and the x-axis there. Okay. Now what we can do is we can actually estimate this area using rectangles. So we use either the left endpoint or the right endpoint method. Okay, and they will actually give you varying results. I'll just move this a little bit, get away from the glare. Okay, so the left-hand endpoint just means the left-hand side of our rectangle is the side that touches our curve. Okay, like we've got here. The right-hand endpoint method means the right-hand side of our rectangle touches the curve. Now you can see in this example, the left-hand endpoint will give an estimate that's less than the actual area. The right-hand endpoint in this case would get a value that's bigger than the estimated area, than the actual area, sorry. And if we actually average those, we get something even closer again. Okay. Okay. But to find the area under the graph, what we need to do is make sure that we actually find the area of each of these individual rectangles. And we always make sure that the width of each rectangle is the same. Okay. And so what we do here, this is an example, okay, we've got some function, and we've got a width for our rectangles of 1, so we're going from 1 up to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. Now you can see I'm using the left-hand endpoint, and again in this case it would give me a value that's less than the actual area. Okay, but that doesn't matter. If we went the right-hand one, we get one that's bigger. Okay, it doesn't matter, it's just an estimate. Okay, so we can see here that the width of each rectangle is 1. Now the height of the rectangle, because this is the left-hand method, okay, then we've got f of 1 is the height of this rectangle. For the next one it's f of 2, for the next one it's f of 3, and then for the next one it's f of 4, and then f of 5. Okay, so the area would be given by 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4 plus 1 times f of 5 for this one. Okay, which is fine. Okay, so it would give us an estimate. Right, would it be that close? Probably not. Okay, but we need to think, well, how could we make this more accurate? Well, we could actually make our rectangles smaller. Okay, so skinnier. So each of these could be split in half. And you'd see that our answer is going to be getting closer to the actual value. Okay, we could do something like that. That gets us much closer. Okay, and that was just making our rectangle heights now a half. Okay, and we could keep doing this. Okay, and essentially it all comes back to limits. So if you like, as the limit of the width of our rectangles approaches 0, okay, then our estimate, okay, is going to approach the actual value for the area under the graph. Okay, and what we find then is the actual way to do this, okay, they're giving us our exact answer, is what we call finding our integral. Okay, so if we were going from some point on our curve, let's call, instead of calling this 1, we're going to call this A, point A up to point B. Okay, then if we find our integral from A to B of this function f of x, okay, with respect to x, this is going to give us the area under the graph. Okay, this will give us our exact value. Okay, so you can get into some pretty specific mathematical notation, which I'm sure all the textbooks do, about writing out what the sum of these means, and writing out our limit as our width of our rectangle approaches 0 and all that sort of stuff. Okay, what's going to happen is they're all going to get to the same idea of this integral for our area under the graph. Okay, and this is going to be a big focus for the next work that we're going to do in maths. So hopefully that video helps you out. Okay, you won't need to do much more in this sort of section other than finding our widths of our rectangles and then using that to find our areas of our rectangles. Okay, other than that, there's not too much to this section, and I'm sure you will go fine with it.